Hello everyone and welcome to my presentation about Matchbox, an open source tooling which can be used for FHIR mapping and validation. My name is Oliver. I'm working for ADIS, which is a small consulting company, and we are consulting around interoperability, and their FHIR and IAG is used quite a lot. And this was also the origin why we started with this open source project of Matchbox. And during this task I want to show you and present you how you can Matchbox for validation and how you can use Matchbox for mapping. Matchbox itself is a microservice. We provide it in a Docker container, and you can use it for FHIR validation and transformation through an API. So there is a small GUI with Matchbox, but the background is that you can execute it as a microservice from your own application or from your own testing environment. It's configurable with different implementation guides. For example, at the IAG Connect.on floor, it is used for IPS, International Patient Summary Testing. In Switzerland, we use it for our exchange formats during the EPR project at DONS. And it has different features. For example, you can configure your own terminology server. We have it not only as a microservice, but there is also an engine, Matchbox engine, which is a Java library which supports the same functionality but not exposed as a microservice. The background of this project started at the HL7 Connect.on in September 2019. We wanted to have a tooling where you can validate our FHIR documents, where we did the specification in Switzerland, and on the other hand we had a project where we needed to map from CDA to FHIR and back. And the core library provided already some of these features, and we packaged it together based on the FHIR JPI server project with the API, that we can release this as an integrated service. We do monthly or bi-monthly updates, and then we upgrade to the core validation and mapping stack. It's everything open source, it's an Apache 2 license, and we provide then also each release with a Docker container, and you can derive specific containers for your specific configurations. And in addition, we have also a test instance for development and a test instance for integration. The project is hosted on GitHub, and we have also set up a documentation website and where you can see all the features which can be used. So if you go to matchbox.health, you see the link to all the different parts, so where the source code is, link to the test server, and also the documentation. The first feature is validation. If you have a FHIR implementation project, you want to ensure that your instances are valid. First, if they are valid as XML JSON, but often afterwards if they are valid according to a profile definition, like for example if a document is valid against the FHIR International Patient Summary or against some other profile definition. If the codes are exact in the example, if the right resources are inside, etc. You often use validation in development, but also a lot during integration, or you might even use it in production. So Matchbox itself puts the focus on integration of production, and there are also other tooling, especially for development. There is the official HL7 FHIR Java validator, which is a Java application you can use to test your resources, and there is a web-based version of that which is validator.fhir.org, where you can enter your resources or upload your resources and validate that against also different implementation guides. Matchbox validation is also based on this HL7 Java reference validator, which each upgrade of Matchbox we upgrade then to the latest HL7 Java validator version, and this is also specified in the results afterwards of the validation. So if you're comparing validation results from earlier time, you see against which setting your validation was done. You can configure Matchbox with different implementation guides. This has the advantage that everything is already configured within Matchbox and no callouts to an external package server have been made, so you can ensure that no data leaves Matchbox in any way. We offer a $validate API call that you can use the validation as a service from your own environment, and an additional feature is that we can preload implementation guide and cache in memory to ensure that you have a fast validation turnaround, especially if you want to consider doing validation in production, that you have quite fast responses. Feature we lately added is that you can ignore warnings and information accounts, that they are ignored. So there are sometimes information and warnings which are very helpful in development, but afterwards if you want to do then with third-party integrators, you don't want to show all the warnings, so you can switch off certain warnings, and they have less worries to do a correct implementation. Matchbox comes also with a little GUI that you can perform the validation yourself. I will present you this also shortly, but the main idea behind this that you use it directly through the API. So maybe let's quickly look how this works. I go to test server, validate resources, and I add the resource I want to validate. The validation will start. If there is a profile mentioned in the meta profile, it will automatically use that implementation guide where this profile is defined to validate, and we see here we have 2 errors which are then showing up here, so that there is a minimum requirement of 4, but we have only 3 entries in here. Now, if we would like to do this validation code through the API, I can show you this also quickly. I'm using here REST client, which is a VS Code extension that you can send to API calls. We support the $validate operation on the system root. You specify the profile against which you want the resource to validate, and you have to provide the resource as the input. And when I do this, this goes against our test instance Matchbox v3, and if I send this request, I should get the same result as we have seen in the GUI. So you see that the information what was done, so which against which profile, against which version, which dependent implementation guides, and in which configuration, everything was validated, and then you have the different result. This is a FHIR operation outcome. If you want to do now validation specific for your project, you can also create your own container based on the Matchbox. For example, we use this in another project in Switzerland where they want to check also during production if each message is correct. So we created a special container, and with this container you then specifically want to verify resources against the profile, and you provide this implementation guide also during the configuration, during the building of the container. So if the container starts, everything is ready. I can also show you this quickly, how this works. We go to I built the container already before, so we run the container, and then the container is started up. So it will now create a new validation engine for this specific implementation guide. It has a own internal terminology server that there are no callouts, and then the validation engine should be ready, and then we can validate this. So this is now not on the test server, this is my own instance. I'm sending here a FHIR bundle to this validator and telling him against which profile, and I want to validate that. You see here the output, and you see here now the result, validation for profile. No issues detected, the validation has been passed. Oh, you have different validation options. You can specify different implementation guides which can be configured. You can also, if you want to, like on the test server, add additional implementation guide later on. You can specify which terminology server which you want to use. You can preload certain implementation guides that they are already cached in memory. However, there's a trade-off because you will need more memory on your validator instance. You can make it a read-only version that nobody can modify anything afterwards. You have everything configured, and as told before, you can suppress warnings if you want to reduce the amount of information or warning messages. Since the target of Matchbox is to be a service behind just offering this validation, we wanted also to add it for the tooling on the Connectathon and Projectathon floor, and we are very glad that we can provide these services together with IHE Catalyst. So Matchbox is integrated into the Gazelle environment, and they configure it for their testing at the Projectathon and Connectathon floors, and I can show you here this also quickly how this works. We have here, during the FHIR marathon, we tested the European lab report. We go to select the WAD report, you upload your example bundle, and then you select against which you want to validate, and then the validation starts. It takes a while because on this Matchbox environment we have different implementation guides and they are not cached, so the first time it will take a while until the validation is done. A second time it should then be much faster, and we see here also the different response messages, the same information as you know it already from Matchbox with the different warnings. This project is far from finished. We have a lot of ideas what we can develop further. What we are currently working on is that EVS client has a new validation API. We would like that we support that also with Matchbox, that you can do more configuration directly and support different. Then another issue is that we don't have yet FHIR Release 5 support, so that's in the work. And if you have any ideas or even a contribution, do not hesitate to contact us. Second feature which Matchbox supports is FHIR mapping. It allows you, based on the FHIR mapping language, to parse and convert to StructureMap resources and then use the StructureMap resources to do transformation, for example, like in Structured Data Capture for questionnaires, or even for mapping like CDA to FHIR. The FHIR mapping language is part of the FHIR standard. It has a textual representation where you can describe mapping between different resources, and these mappings can then be transformed to a FHIR StructureMap resources and can then be applied automatically through the transformation service. One place where this can be used is in Structured Data Capture. Structured Data Capture is an initiative and an implementation guide of HL7. Our questionnaires are an excellent tool for data capture. However, the result of those different questionnaires is then not very easy searchable or easy integrated with discrete data sources, and then the general recommendation is that you use FHIR for your questionnaires for raw data capture, but then convert the resulting questionnaire responses into FHIR resources. And this converting to FHIR resources are different possibilities, and this is also described in this implementation guide. And one of the possibilities is that you use a StructureMap based extraction. And this works like this, that you have a questionnaire response, which are the answers of the questionnaire. Then this questionnaire response points to the questionnaire where the questions are defined, and the questionnaire then links to a structure map, and this structure map should then be applied to the questionnaire. So if the mapping engine sees that questionnaire or is called with that questionnaire response to extract the data, it will resolve the questionnaire and it will check the structure map and will apply then the structure map to this questionnaire response and transform the result. That can then be, for example, a bundle FHIR resources or whatever that structure map defines as output. I can also demonstrate this you quickly how this works with Matchbox. Since we upload here resources which have to be afterwards available to the engine, we are working here with the development environment, and that we have only one engine, because otherwise we won't find the resources again. We will switch back to VS Code. All these files you see, they are also available in the FHIR repository if you want to try it yourself. We are using here the development version. This is also shown when I click send request. The server returns me the capability statement and then says here in the development mode. And now I can, for example, upload a structure map. This is a very simple structure map. It takes a questionnaire response and converts it to a patient, and it has just converts just the patient sex questionnaire response to the target gender in the patient. So what I do now is I post this FHIR mapping language to the structure map endpoint, and this will return me, if I have made no errors, the structure map resource, which then I can use for further for the transformation. Can also check that this is StructureMap resource is available on the server. And now what I want to do is call the transformation function. So this is post StructureMap transform. I specify the map which I want to use, and then I send the input, the questionnaire response, where I have the patient sex in the questionnaire response was set to male. I do the send request, and now the transformation is applied, and return I get the patient resource where the gender is set to male. If I would put it here to female, that would change to female. So structured data capture defines questionnaires, and this questionnaire where we just sent the answer before could look like this. So I have an item with this patient sex inside and the reference to the StructureMap here. So if I upload that questionnaire to the server knows now the questionnaire, and I can now, like structured data capture defines, post that questionnaire response to the server and invoke the $extract operation, and the mapping engine then will check for the questionnaire first, take out the reference StructureMap and apply the StructureMap, and it should happen the same as we did before directly. So we get back the patient female response out of this questionnaire response. So this is what we did just before in the presentation. We use the same approach also for CDA to FHIR mapping. CDA is a clinical document standard, and HL7 has created a logical model for that. So logical model is a description of the CDA standard. This will not give us an API for a FHIR servers, but it describes how this CDA logical model is defined with FHIR profiles and constraints, and then we can use it for like validation or mapping like we have seen before. So we provide the CDA logical model, which is an implementation guide to the mapping engine, and then the mapping engine applies the maps and can apply this mapping to the CDA to FHIR. You need to write the map so that this is supported. This is not out of the box. We use this, for example, in a project in Switzerland and now also in one in Italy to help support this transformation. So we here see left this clinical document, and then we, if the maps are uploaded, you can then do this transformation and you receive a FHIR bundle. Can also show you this quickly, how this works with Matchbox. So we use this CDA mapping tab, check if the server is available, quickly also check if this logical model is here with this clinical document definition. Since it's the development server, I will upload all the maps, not that somebody else has maybe in the meantime changed those maps. And these are 3 different maps. They are coming out of this project, and then afterwards now I have a sample CDA document which I want to transform, and if I do send request, it should give me this result, which is here a FHIR bundle, and this CDA information has now been transformed into the FHIR document bundle. Okay, so currently Matchbox is used mostly for conformance testing, for example at the Swiss EPR project.on or at the IHE Connect.ons. We have a project where it will also go in production for validation in Switzerland. Another company is using it for the questionnaire response to FHIR bundle mapping for vaccination. And we have also a project where the library is used in Italy to CDA and FHIR mapping. So if you have interest in using Matchbox or contributing to Matchbox, please do not hesitate to contact me, and thanks a lot for your attention.